This is a video for AQA Mechanics, Center of Mass and Moments, Section 2.4, Sliding and Toppling. Well, here's an object that we've looked at in previous videos, and we found, if you remember, the center of mass would lie along the line of symmetry, of course. We found that its position was 3/16 of a centimeter from the line where the two objects join together. So that this distance here was equal to 3/16 centimeters. Well, if we mark then the weight of the object onto the diagram acting at its center of mass, we can see that there's a pivot point here, and that mg is therefore going to provide a turning moment. So what will happen is, of course, the object is going to turn about this pivot point until it lies flat on the ground, as in this diagram. And then we'll have the weight and the normal reaction equal and opposite to each other, so it will then be at rest in equilibrium. In general, if we've got an object which is sat on a rough surface and we're going to push it with some force, let's call that force P, then different things can happen depending on the size of the frictional force. Now, it's possible that what will happen is it will begin to slide. So we then have the fact that we'll have the weight mg and the normal reaction here, but the pushing force here is going to overcome the frictional force which is acting so that it will slide along the ground. However, if the frictional force isn't overcome, then what happens is that we'll get a turning moment about this point, and so the object will begin to topple. Here's an example of that, and what we want to do is to find the value of P which would cause firstly the box to slide and secondly for the box to topple. We're given that the mass of the box is 10 kilograms. We've got a coefficient of friction, so mu is equal to 0.3. The height of the box is 1.5 meters and width 0.8. Well, let's first consider the situation when it begins to slide. In that case, we'll have a frictional force which is opposing the motion equal to mu multiplied by r, where r is the normal reaction, and of course the vertical force is mg acting downwards and the normal reaction upwards, equal and opposite. So we can say that r must be equal to mg, which is just 10 multiplied by g, which is 98 newtons. So the normal reaction 98, and therefore the maximum frictional force, if we can have mu r, we're in limiting friction, and therefore we have that the value of F, the frictional force which is maximum, is equal to mu times r, and that's equal to 0.3 multiplied by 10g, which comes out to be 29.4 newtons. So we can say that P equal to 29.4 newtons would cause the box to slide. In the second situation, then if it's going to topple, it's going to turn about this corner here, so that the forces involved are the weight mg acting down from the center of mass and P. We know that the height of the box is 1.5 meters and the width of the box 0.8, so we can say that mg acts at a distance of 0.4 from that pivot. So if we take moments about the corner, where it's toppling, that is, then we can say that we've got an anti-clockwise moment of P multiplied by 1.5 must be equal to the clockwise moment, which is mg, so 10g multiplied by 0.4. And if you calculate that, we get that P obviously is 10g 98 multiplied by 0.4 over 1.5, and that turns out to be 26.1 newtons. So if P is 26.1 newtons, then we have the box is going to topple. So those are our two results. It will begin to slide if we can get P to be 29.4 and topple if P is 26.1. Now obviously, therefore, it's going to topple before it begins to slide. So we can say that the box will topple before it slides. Here's a slightly different question then, this time concerning box which is on a slope, and we can vary the angle of the slope, and what we want to know is how far can we vary that, what's the greatest angle such that the box is just not toppling. In other words, what we say is it's on the point of toppling. Now we're assuming that the frictional force on the slope is great enough to stop it sliding down the slope. Well, on the point of toppling then, we must have the fact that the weight of the object, which is coming from its centre of mass obviously, is acting through this corner. If it was to go any further than that, then we would have a turning moment about that corner, and so it would begin to topple. So this is on the point of toppling. We can say that the force acts through the corner, the force being the weight of the object. So if that's the case, all we need to do is to work out the trigonometry of this. That angle theta is also equal to this angle here, and we know that the box is 1.5 high, so that must be 1.5 divided by 2, and it's 0.8 wide, so 0.8 divided by 2. So we have therefore a triangle in which we've got theta is tan to the minus 1, the opposite side is 0.4, and the adjacent side 0.75. And if you calculate that, theta turns out to be 28.1 degrees to 1 decimal place. That concludes this video on sliding and toppling. In the next one we'll be looking at the idea of a couple.